This is the circuit that we have with us, and here we are to find out Z parameters. This is a pi circuit, so the solution will not be as easy as a T circuit. So let's just solve the question. Let us first find out Z11. We know that the formula of Z11 is V1 by I1 when I2 is equal to 0. And Z21 is equal to V2 by I1 when I2 is equal to 0. So first we will assume that I2 is equal to 0 and the circuit is open. Let us name the nodes. So now we are assuming I2 is equal to 0. So if we look at the circuit from terminals A, E, we can write the equation V1 is equal to I1 R equivalent, where Req is the equivalent resistance of all the resistances present in the circuit. So let's just find out R equivalent. Since I2 is equal to 0, so 3 and 5 ohm come in series, which in turn come in parallel with 2 ohm, which is again in series with 1 ohm. This is R equivalent. Let us just solve it. 8. This is a shortcut that you can use if you want to take. You can take the longer path, but you can use it only for 2 resistances. So the R equivalent turns out to be 2.6 ohm. Now V1 is equal to I1 into 2.6, and we are solving this entire equation assuming that I2 is equal to 0. So V1 by I1 is equal to 2.6 ohm turns out to be the value of Z11. So we have received the first value, that is Z11. Let us write it over here. Now in order to find out Z21, there is an involvement of V2. So we need to find out V2. V2 is a voltage drop across CG terminal, which means voltage drop across 5 ohm. Let us assume that the current that is flowing through is Ix. So the current that is flowing through CG is Ix. So V2 will be 5 into Ix or 5Ix. Now I have to find out the value of Ix, which I can do simply by using current division rule. So Ix is equal to the current that is being divided, which is I1 is being divided into 2 parts. One part of I1 is going in BF and another part of I1 is going in BCG. So according to current division rule, total current I1, resistance in another branch that we are not finding the current of, which is 2 ohm, and in denominator the addition of resistance of both the branches. So 3 ohm and 5 ohm come in series, so the resistance of BCG will be 3 plus 5 addition resistance of other branch, which is 2 I1 divided by 10, which turns out to be 1 by 5 I1. That is the value of Ix, ampere. Now I am simply going to put the values here. V2 is equal to 5 into 1 by 5 I1. From this Z21 formula, the value of Z21 is found out by V2 divided by I1 when I2 is equal to 0, and we are solving this equation so far assuming that I2 is equal to 0. So let's just put the value. This will be cancelled out, that is I1. The value of V2 is I1 divided by I1, that is 1 ohm. So the value of Z21 we received as 1 ohm. We have solved for Z11, Z21, which means we found out 2 parameters. We are left with 2 more. So the value of Z22 is equal to V2 by I2 when I1 input current is 0, and Z12 is equal to V1 by I2 when again input current is 0. Now we'll solve this circuit assuming that I1 is equal to 0 for these 2 parameters. Now in situation 2, the current I2 is flowing while the current I1 is 0. So there is no current through 1 ohm, so it will not be considered in calculations. If we look at the circuit from the viewpoint of DH, from the terminal DH, we know that the value of V2 is equal to the current that is flowing through in circuit I2 multiplied by R equivalent. let's call R equivalent dash. So let's just find out the R equivalent dash. So we see the 3 ohm and 2 ohm are in series now, because the current that is flowing through 3 ohm is the same current that is flowing through 2 ohm resistance as well, because none is flowing through 1 ohm, because I1, which was the current that was meant to flow from 1 ohm resistor, is 0. So first add these two which are in series, which are again in parallel with 5 ohm. There is no resistance here, so let's just solve it. 5 in parallel with 5. So let me tell you the trick. When there are two equal resistances in parallel, you can simply divide the value by half. That will be the answer. So it is 2.5 ohm. You can solve this with the detailed method as well. So we have got R equivalent dash is equal to 2.5 ohm. So the value of V2 is 2.5 I2 voltage. Now from the formula, Z22 is equal to V2 by I2. Let's just put the values. 2.5 I2 divided by I2. We put this value here, 2.5 ohm. The value of Z22 is, so the value of Z22 we find out to be 2.5 ohm. Now let us find out the value of Z12. We're still assuming that I1 is equal to 0, because in order to find these two values, I1 has to be 0, that means input current has to be 0, that means input circuit has to be open. Now that no current is flowing through AB, that is 1 ohm resistor, the value of V1 will be the voltage drop across B and F, these two terminals, which means the voltage drop across 2 ohm is the value of V1. Let us assume that the current flowing through here is IY. V1 is equal to 2 into IY. Similar calculation, we are going to find the value of IY with the help of current division rule. So what current is being divided here? That is I2, which means total current multiplied by, now let's see, the current is being divided at this point, C. Okay, one part is going through 5 ohm resistor, another part is going through CBF, which means 3 ohm and 2 ohm are in series. So the current that is flowing through 2 ohm is the same as flowing through 3 ohm, which means current is being divided into two parts, CG and CBF. We have to find out the current across 2 ohm, which is a part of CBF. So in numerator, we'll put the value of CG, that is 5 ohm resistor. And in denominator, the addition of resistances of these two branches. So what is the total resistance of CBF? Is 2 plus 3. Why? Because they are in series. Resistance. And what is the resistance of other branch? 5 ohm. Let's solve it. 5I2 divided by 5 plus 5, 10. If we solve it further, I2 by 2, IY's value is I2 by 2 ampere. Why am I doing this calculation? In order to find out V1. So let's just put the value of IY here, 2 into I2 by 2, I2 voltage. So the value of V1 is I2 voltage. So now we'll just simply put the values here. Z12 is equal to, put the value of V1, I2, and in denominator I2, it turns out to be 1 ohm. So this is how we found out all the values in a pi circuit. Now you might notice one thing, the value of Z21 is equal to 1 ohm, the value of Z12 is equal to 1 ohm. So when Z12 is equal to Z21, it shows that this entire network is bilateral in nature.